Hello, today we are factoring sums and differences of powers. So a squared minus b squared factors into a plus b times a minus b. So for example, if we think of, well, you know what? If you multiply this through, let's just do it that way. So a plus b, a minus b, you get a squared minus ab plus ba, which is the same as ab. Minus b squared. And so that's why you get a squared minus b squared, is because the middle terms cancel out. When you have a squared plus b squared, we talked about this a little bit in 2 days ago's lesson, the complex numbers lesson. A squared plus b squared factors into a plus bi times a minus bi. Let's multiply that out and just prove it to ourselves again. A plus bi, a minus bi. So we get a squared minus ABI plus ABI minus B squared I squared, but I squared is -1. Middle terms canceled, negative B squared times -1 is a plus, hence A squared plus B squared. So we're just going to do examples. So 4x squared minus 25y squared. We're going to factor completely. So basically what we're going to do is we can rewrite this. I see a minus, and I can rewrite this as 2x in parentheses squared, because 2 squared is 4, x squared is x squared, minus 5y in parentheses squared. Okay? And so once we write it in that form, something squared minus something squared, then it's going to be 2x plus 5y times 2x minus 5y. Okay, so whatever our two things are, 2x and 5y in this case, we add them in the first binomial and we subtract them in the second. And you can always prove it to yourself and make sure you're right by multiplying and seeing if you get your original. Next one, x squared plus 25, there's a plus, and I can write this as something squared plus something squared, x squared plus 5 squared, and whenever it's a plus, the pattern is first term plus second term times I. So x plus 5i times first term minus second terms times I, x minus 5i. Here's another one. So I can write m to the fourth as m squared squared, and I can write 81n to the fourth as 9n squared squared. So using our pattern, a plus b times a minus b equals a squared minus b squared. So this plus this minus this this plus this times this minus this. Easier in person, guys, I apologize. So we get m squared plus 9n squared times m squared minus 9n squared. But here's what happens with this one. We can actually refactor both of these. We can factor them again because m squared plus 9n squared is the same as m in parentheses squared plus 3n in parentheses squared, and m squared minus n squared is the same as m in parentheses squared minus 3n in parentheses squared. So then we can use our rule, both of them actually, when it's plus, it's m plus 3ni times m minus 3ni. We tack an I on the second term if it's plus, and then times m plus 3n times m minus 3n. So there's our fully factored answer. Sum and difference of cubes. So this is a little trickier, but it really is just a pattern. And the difference is here, there's a plus, and then it goes plus, minus, plus. If there's a minus in between, it goes minus, plus, plus. So it's all about patterns. So x cubed plus 125. So first of all, we can write this as x cubed plus 5 cubed. Then if you look up above at the one with plus, at that first one, it's going to be first term plus second term. I'm going to talk about the x's and the y's as like the first and the second term. So first term plus second term times first term squared, which is x squared in this case, minus the terms multiplied together, which is 5x, plus the second term squared, which is 5 squared, which is 25. And that's our answer. For the next one, I see cubes, so let's see what we can do here. I can write 27a cubed as 3a in parentheses cubed, and 8b to the 6th is 2b squared in parentheses cubed. And we're going to use a formula again. And so really I think of the x's and the y's up here as just first term and second term. So to factor this, we get first term minus second term times first term squared, 3a in parentheses squared, plus, right, because we have a minus, then it goes minus and then a plus. The two added together, so that's 3a times 2b squared. And then plus second term squared, which is 2b squared squared. All right, let's simplify a little bit. So we have 3a minus 2b squared times, let's see, 9a squared, plus 3 times 2 is 6ab squared. 2 squared is 4, b squared squared is b to the 4th, so plus 4b to the 4th. And there's our answer. So this one, the trick here is that technically you could use difference of squares or difference of cubes, right? So you could say x cubed, sorry, help if I could write. We could say x cubed squared minus 8 squared, or we could say x squared cubed minus 4 cubed. You will end up with the same answer either way, you just might get there a different way. I'm going to choose the cubes, the difference of cubes, but either one will work. So if we write it as x squared cubed minus 4 cubed, we start with a minus, and so it's going to be first term minus second term times first term squared. X squared squared is x to the 4th. You know what, I'll write it out as x squared squared, that might help a little bit. So x squared squared plus, because if we go up here when it's minus, it goes minus plus plus. The two terms multiplied together, so that's 4x squared. Yep, minus plus plus, so we have another plus. The second term squared, which is 4 squared. So we have x squared minus 4 times x to the 4th plus 4x squared plus 16. But guess what? X squared minus 4 is the same as x squared minus 2 squared. So this one factors again. X plus 2, x minus 2, and then we bring down our x squared plus 4x squared plus 16. We are going to skip the rest of this at this point, okay? Because I'm a lot more concerned with the part that we've already done. So make sure you can do the parts of the homework that go with what we've done, and then you'll be all set. So do not worry about the rest of this and the homework problems that look like stuff we haven't done. Do not worry about it.